Hey guys, last week we learned how to use trigonometry, SOHCAHTOA, to find the missing side lengths. This week we're going to use SOHCAHTOA to find missing angles. So you'll be given two sides, or at least two sides to a triangle, and be asked to find the missing angles. We will also do some word problems afterwards that will be a combination of finding missing angles or finding missing sides. So kind of a review of this week and last week. So our objective this week is to use trigonometric ratios in order to calculate missing angle measures in right triangles. So again, this only works with right triangles. That's the only way we can use trig. So getting to our notes that I attached to your file, or into your email. Here we go. Alright, so this is week 10 of working from home in 2020. So we are going to be finding angle measures using trig. So these are our notes. Use right triangle trigonometry to find the missing angle measures in the given triangle. So the way I have these notes set up is on this left side is just this whole problem. This is the steps to solve, find angle A. On the right side, these are the steps to use to solve to find angle B. Okay? So that's how this page is broken down. So setting up the trigonometric function for A. First things first, what's our reference angle? If you're trying to find an angle, then whatever that angle is, that's your reference angle. So angle A is our reference angle. Okay, and we got that from here. What sides are we given? So the two sides that we know the lengths of, those are our two sides. So I'm going to use blue for my pen for working on the left side, and I'll use a different color for working to find angle B. So if A is our reference angle, then this side that we know here, the 7-inch side, that would be our opposite side because it's opposite from angle A. And then hypotenuse side is always over here. And then that leaves this other side that we know as our adjacent side. So the two sides that we know are the opposite side, because it's 7 inches, and we know the adjacent side. Sorry. And it's 4 inches. So those are the two sides that we know. We can put in parentheses. That one's 7 inches. This one's 4 inches. Okay? Now, next we have to think, well then, which trigonometric function uses those two sides? Uses opposite and adjacent. So I'm going to go ahead and write at the top here, SOHCAHTOA. Whenever you're doing trig, it's always good to have that on your paper. So if we're using opposite and adjacent side, the one that uses opposite and adjacent is tangent. See the opposite and adjacent, so it's tangent. So we're using tangent for this. All right. So now that we figured out which trigonometric function we have to use, then we're going to go ahead and set up our trigonometric function to be able to solve for that missing angle. So down here, we're going to try to solve for a function of x. So set up the correct trigonometric function with the correct ratio. So since we're using tangent, we use tangent. Our angle is angle A, so it's tangent of A is equal to the opposite side over the adjacent side. And we get that from our SOHCAHTOA. Tangent equals opposite over adjacent. Okay? And since we know those sides, I'm just trying to read ahead. Since we are looking for an angle, we must use the inverse. Okay, so since we know those sides, instead of, I'm going to go ahead and rewrite it. It's tangent of A equals opposite over adjacent, so 7 over 4. This is our trigonometric function. So now that we have tangent of A, I'm going to go ahead and write it again here, is equal to 7/4. then our goal then is to get A by itself, okay? So since we're trying to find that angle A, we need to get rid of the tangent on that side so we can get it by itself. The way you get rid of tangent is you take the tangent inverse of both sides. And tangent inverse just looks like tangent with a -1 exponent. That's how we write tangent inverse. So tangent inverse of tangent of A is equal to the tangent inverse of 7/4, because whatever you do to one side, you have to do to the other. So going from our trigonometric function that we set up, to get A by itself, we have to do the tangent inverse so that the tangents cancel out. And whatever you do to one side, you got to do to the other. So since we took the tangent inverse of this side, we have to take the tangent inverse of 7/4. So what that does is it gives us our equation now is A, because we got A by itself, is the tangent inverse of 7/4. And this is what we're going to have to enter into our calculator. So let me pause the video for, well, no, I'll just go ahead and look it up. So, and I'll put the link to that calculator in your email for this week again, so that you can use that same online calculator to find this. So this is what we're going to have to type into the calculator. Let me look up that calculator real quick. And all I do is look up online trig calculator. That's the way I found this calculator. And then I used the one that says calculator.net and then math. Alright, so here's that calculator we used last week. So now we're trying to find tangent inverse of 7/4. So remember up here we used these three, sine, cosine, and tangent last week. Make sure it's in degrees. See how degrees is highlighted. Then down here is sine inverse, cosine inverse, and tangent inverse. We're using tangent inverse, so click on, so it says arctan. So when you hit tangent inverse, it'll say arctan up on here. Some calculators will say tangent inverse. Either way, it means the same thing. And then 7 divided by 4. And then you can either hit equals, or you can already see that it's highlighted in blue here. So our answer is 60.25. Let's just go ahead and round this to the nearest 10th position. So it should be 60 point, if it's 0.25, then this 5 tells us we need to bump up that 2 to a 3. So it's 60.3 degrees. So going back to our paper, angle A is equal to 60.3 degrees. Okay, and that's what we're learning this week, is how to use trig to find a missing angle. So like I said, I'm going to switch colors of pen so that on my diagram you'll be able to see which ones we used for A and which ones we used for B. So now, since we're trying, so we got A was 60.3. Now let's use trig to find angle B. So angle B is our new reference angle. Okay, so that's why it's in pink now. Now it's our new reference angle. So we have a new opposite side. So this now is our opposite side. And hypotenuse is always a hypotenuse, because it's always the side across from the 90-degree angle. And then our new adjacent side in pink is the 7-inch side. So our reference angle is the angle we're trying to find, so angle B. The sides that we're given, we're still given the opposite side, but this time our opposite side is the 4-inch side. And then we're still given our adjacent side, but this time the adjacent side is the 7-inch side. Okay? Because it's all dependent upon the reference angle. Okay? So which trig function will we use? Well, opposite and adjacent, when you're looking at SOHCAHTOA, is still tangent, because tangent equals opposite over adjacent. So we're still using tangent to find our angle B. So we set up our trig function. Tangent of B is equal to opposite over adjacent, but in this case, tangent of B, our opposite side, so the side opposite angle B is the 4-inch side, so it goes 4 over the adjacent side to angle B, which is the 7-inch side. So our equation is set up then as tangent of B, angle B. Your angle always goes in the parentheses. Sorry, let me bring that up. Our angle always goes in the parentheses there, next to the sine, cosine, or tangent. And then 4/7. And just like with the last problem, we're wanting to get that angle by itself, because that's what we're trying to solve for. So to get B by itself, we need to get rid of the tangent, so we have to do tangent inverse. And whatever you do to one side, you do to both sides. So we're doing tangent inverse of tangent B, and we're doing tangent inverse of 4/7. So by doing that, the tangent inverse canceled out the tangent, leaving B is equal to tangent inverse of 4/7. And that's what we have to type into our calculator. So going back to our online calculator, we're doing, let me clear this out, tangent inverse of 4 divided by 7 is 4/7. And we get an answer of 29.7. And you notice since this is a 4 next to the 7, to the right of the 7, that 7 does not bump up. It stays the same. So 29.7 degrees. So B equals 29.7 degrees. And with this problem, we could always check ourselves to see if these answers work out right. Remember, with a triangle, all 3 angles always add up to be 180. So the one right angle is 90 degrees, plus 60.3, plus 29.7. Add all those 3 up, and we do get 180 degrees. So that is, those answers are correct. Okay? Now remember, if I ever go too fast, always just pause, rewind, do what you got to do. Rewatch the video. We're going to do some more practice problems together now. And these are all, let me tone down the brightness a little bit. These are all just finding missing angles. Okay, that's a little bit better. Okay. Now, on this, going back to that first page real quick, on this one, after I found that this angle was 60.3 degrees, I could just go ahead and take 180 minus the 60.3 minus the 90 to get that third angle. So, but however, the only problem with that is if I made a mistake in figuring this out, then both answers would be wrong. So the nice thing about figuring out both of them this way is then at the end, if they add up to be 180, then you know you did everything right. All right. So we're going to try to find our missing angles on some of these problems. I'll probably do like 3 of these. I don't find it necessary to do all 6 of these because I do want to do a mixture of problems where we find the angles and we find the sides. So on this one, we're going to find angle B and angle C. So let's start with angle B. We got to set up our, and I'm going to go ahead and put SOHCAHTOA at the top here. SOHCAHTOA, SOHCAHTOA. So that we can reference that for our formulas. So for finding angle B, our opposite side is that 5 centimeter side. Our hypotenuse side is always across from the 90-degree angle, and our adjacent side is the one left over. Okay? So, sorry, I always get these alerts. There's 2 sides that we know. Now that we have all 3 sides labeled with according to angle B, and remember, whatever angle you're trying to find, that's going to be your reference angle. So the 2 sides that we actually know the lengths of are opposite and hypotenuse. So, opposite and hypotenuse deal with sine. Sine equals opposite over hypotenuse. So we're going to do sine of B equals the opposite over the hypotenuse side, so that would be 5/7. Okay? And then our goal is to get b, now that we have our trig function set up, our goal is to get b by itself, so we have to get rid of the sign. To get rid of the sign, you do sine inverse of both sides. So sine inverse of sine of b equals sine inverse of 5/7. Okay? That cancels out my sine, so I'm left with b is equal to the sine inverse of 5/7, and that's what we have to plug into our calculator. I'm also going to zoom this in a little bit in case some of you are looking at this video on your phone. It might be kind of hard to see if you're looking at a small screen. So zoom that in a little bit. So going back to our calculator, we need to type in, clear this out. Now we're doing sine inverse of 5/7. So 5 divided by 7. And our answer is, when you round to the nearest tenth, 45.6. That 5 bumps up to a 6. So going back to our worksheet, 45.6. So there's our angle B. If you want, you can use trig to find the other angle C, or you can just take 180 minus the 90-degree angle there, and then minus the 45.6 degree angle B, and that should get you your angle C. So clearing that out, 180 minus 90 minus 45.6. And we get 44.4 degrees. So angle C is 44.4 degrees. Okay. Next, I'm going to kind of just alternate going diagonally. I'm going to go to this next problem here. Now in this one, they actually gave us all three sides. So let's pick an angle that we need to find. I'm going to pick angle T this time. Sorry if you hear my husband in the background. He's working from home too. So I'm going to pick angle T as my first angle I'm going to try to find. Across from that is my opposite side. That's that length of 7. Our hypotenuse side is always across from our 90-degree angle, and then the last one left over is our adjacent side. Okay? So we need to set up an equation that, and when we're doing these, we need to set up an equation where we, using the two sides that we know. Well, in this case, we actually know all three sides, so you get to choose whichever one you want to use. So since I've already done example problems using tangent, I've already done example problem using sine, I'm going to go ahead and use cosine on this one. So I'm going to do cosine of angle T, and you only get to choose which one to use if you know all three sides. If you only know two sides, then it's chosen for you. So cosine of angle T, and cosine, going back up here, cosine equals adjacent over hypotenuse. So from angle T, our adjacent side is 24 over the hypotenuse side, which is 25. So that's how you set it up. And then now that you have it set up, you just got to work towards getting T by itself. So we have to take the cosine inverse of both sides. Okay, so that leaves us angle T is equal to the cosine inverse of 24 over 25. And that's what we're going to have to type into our calculator. So going back to my online calculator, cosine inverse of 24 over 25. Oops, sorry. So clear that out. This time we're doing cosine inverse. 24 divided by 25. and we get 16.26. So that 2 actually becomes a 3 because that 6 bumps it up 1. Remember, if that number to the right of it is 5 or greater, it bumps it up. So it'll be 16.3 degrees. So angle T is 16.3. Then we can find angle C by just taking 180 minus 16.3 minus 90. And that tells us that last angle left over. So 180 minus 16.3 minus 90, and we get 73.7. So there's our 2 missing angles. So if you've noticed, last week when we were finding missing sides, we used just sine, cosine, and tangent. This week when we're finding angles, we have to use sine inverse, cosine inverse, and tangent inverse. And it'll always be that way. So just know if you're finding an angle, you got to use the inverses. If you're finding a side, then you just use the regular sine, cosine, and tangent. All right, let's do one more on this page. I'm going to go ahead and go diagonally again. So we've got, let's go with, and it doesn't matter which angle we find first, just know whatever angle you choose, that's going to be your reference angle. So I'm going to go with A, making this my opposite side, this my hypotenuse side because it's across from the 90, and then this one my adjacent side. That is so important. I can't stress enough that you have to, when you're doing trig, label based off your reference angle, what's the opposite side, what's the hypotenuse side, what's the adjacent side. That should always be step number 1. Then from there, the 2 sides that we know is the opposite and the adjacent. So going back up to SOHCAHTOA, that's opposite and hypotenuse, that's adjacent and hypotenuse. Tangent is the one that uses opposite and adjacent. So it's going to be tangent equals opposite over adjacent. So tangent of A, because A is our reference angle, is the opposite over adjacent, so 5 over 15. Now that we have our trig function set up, now we just got to solve for A. To get A by itself, we got to get rid of the tangent, so we do tangent inverse. So that tangent inverse gets rid of my tangent, so I'm left with A, scooch this up a little bit, is equal to the tangent inverse of 5/15. So that's what we'll type into our calculator. Clear this out. Tangent inverse of 5 over 15. So 5 divided by 15. We get 18.43. The 3 means the 4 stays the same, so it's 18.4. So angle A is 18.4 degrees. Now we got to find angle B. So angle B equals 180 minus 90 minus 18.4. So 180 minus 90. Oh shoot, I forgot to clear it out. So 180 minus 90 minus 18.4. We get 71.6. Now the only downfall to doing it this way, like I said earlier, is if I made a mistake in figuring out what A was, then I definitely will make this mistake on B. So I would get both of them wrong rather than just one of them. So if you want, you can always do like what we did on our first example, where we did one color for reference A, for finding angle A, and picked a different color to figure out our new opposite, adjacent, and hypotenuse for angle B, and find that using trig for both angles. That way we can double check ourselves. But if you're confident in your work, then you can go ahead and take this route and take that risk. All right, I want to do some examples that's a mixture of finding an angle, finding a missing angle like what we're doing this week, and finding a missing side like what we did last week. So for our notes here, I got some more examples here. It says directions. Determine if you're calculating first whether it's a missing side or a missing angle, and be sure to set up the correct trigonometric ratio and then determine the missing value. So we'll probably do like 4 of these for examples. All right, for number 1 here, notice that little Greek symbol there, that's theta. That means the variable, that's a variable for an angle. So if they have the variable for the angle theta there, then that means that's what we're trying to find. We're trying to find that missing angle. So I am finding, in this case, angle A. Okay, so that would be my reference angle. Whenever you're finding a angle, then that's that angle is your reference angle. Okay. Now, if you look, we're going to work this out here in just a second. But if you look to the third one here, notice how there's an X on the outside of the triangle. That means we're trying to find that missing side. So for that one, we're finding a side. Okay. So the way we solve these will be different whether we're using, let's say, tangent versus tangent inverse. If you're finding an angle, you're using inverses. You're going to end up having to use the inverses. If you're finding a side, then you're just having to use the regular tangent, or sine, or cosine. All right, so let's go back to this first one. On this one, we're finding an angle. This is the angle we're finding, because that's where the theta symbol was. And so that's our reference angle. So based on that reference angle, here's our opposite side, here's our hypotenuse side, and here's our adjacent side. Okay? So we need to set up our trigonometric function based on the 2 sides that we know. So since we only know 2 sides, we have to use these 2 sides. So I'm going to go ahead and put SOHCAHTOA up here again. It's always a good idea to put it on your paper so you have those formulas basically right there for you. So using SOHCAHTOA, we need to pick the one that uses adjacent and hypotenuse, because those are the 2 sides that we know the lengths of. So the one that uses adjacent and hypotenuse is the middle one, cosine. So remember, S at the beginning, that stands for sine. This C stands for cosine, and this T stands for tangent. So this stands for sine equals opposite over hypotenuse. This stands for cosine equals adjacent over hypotenuse. And this stands for tangent equals opposite over adjacent. So since we're using cosine, the ca, it's cosine of our angle A, that's the one we're trying to find, is equal to adjacent side over hypotenuse. So it's equal to 12 over 13. And then once you have your trig function set up, then it's all about getting that variable by itself. So in this case, our variable is an angle. To get that angle by itself, we have to get rid of the cosine, so you have to do the inverse. Cosine inverse of both sides. By taking a cosine inverse of both sides, that cancels out that cosine, leaving just A equals the cosine inverse of 12/13. And that's what you have to type. Now that we have our variable by itself, that's what you type into the calculator. Cosine inverse of 12 divided by 13. So clear this out. Cosine inverse 12 divided by 13. And then our answer is 22.6 when you round to the nearest 10. And that's all they want us to find. You're either just going to be finding a single angle or a single side on each one of these. You're not having to find all of them. So angle A is 22.6 degrees. All right. Going to the next one, we'll just do these top 3 here. Actually, I'm sorry, we're going to do the top 3 and then the first one on the bottom. All right, so I'm finding the variable is theta, so we're finding that angle. Again, it just happens to be in the same location. That won't always be the case. So angle B is what we're trying to find. So based on that angle, that's our reference angle. So then that side is our opposite side. Across from the 90-degree angle is our hypotenuse side, and then that leaves that 14 side as our adjacent side. Again, based on the two sides that we know, because we only know two in this one, we're going to be using opposite and adjacent, because that's 7.7 and that's 14. So the one that uses opposite and adjacent is tangent. Tangent equals opposite over adjacent. So we set it up as tangent of B is equal to the opposite side, 7.7, over the adjacent side, 14. So again, here's our reference angle B. Across from it is the opposite side that we know. And then we know the adjacent side to angle B is 14. Since those are the two sides we know, that's what we use. So opposite over adjacent, 7.7 over 14. And then, since we're finding an angle again, we're going to have to use inverse to get that angle by itself. So we've got to use tangent inverse of tangent B is equal to tangent inverse of 7.7 over 14. So by taking the tangent inverse of both sides, that cancels out that tangent, so we're left with B is equal to tangent inverse of 7.7 over 14. And that's what we'll type into our calculator. Tangent inverse of 7.7 divided by 14. Clear this out. Tangent inverse of 7.7 divided by 14. And we get 28.8 when we round to the nearest tenth. So since we're not finding all the angles, we can't really double check ourselves to see if we got that correct. So it's just trusting your work. So these two are like what we did this week. This one is going to be like what we did last week when we're finding a missing side. So since the variable's on the outside of the triangle, then that's the side we're trying to find. So since we're finding a side, we got to look, well, which angle do they give us? They gave us angle A is 32 degrees, so that's going to be our reference angle. Figure out your opposite, your hypotenuse, and your adjacent sides based on that reference angle. And then we're going to set up our trig function. So, when you're finding a missing side, remember, you got to use the side that you're trying to find. So in this case, that's our opposite side. And we got to use the side that we know. We only know the one side, which is the adjacent side. So we're going to have to use opposite over adjacent. And again, that happens to be tangent. Tangent equals opposite over adjacent. So we're using tangent, and then in the parentheses is always the angle. We're doing angle A, but I don't want you to put an A. We know that angle, so it has to be 32. Is equal to x, because we're doing opposite over adjacent, so x over 13. So that's us setting up the whole trig function. When you're finding a missing side, the angle that you know, that's your reference angle. Use that angle to figure out your opposite, adjacent, and hypotenuse sides. And then when you set up your trig function, you have to use the side that you're trying to find, your missing side that they want you to find, and the side that you actually know the length of. Because remember, you can only have one variable in there. So we have to do tangent of whatever that angle is, 32 degrees, is equal to opposite over adjacent, so x over 13. Now, once you've got your function set up, again, your goal is to get your variable by itself. In this case, our variable is the x in the numerator here. So to get it by itself, we have to get rid of that 13. So since 13 is in the denominator, we just multiply both sides by 13. So we're left with 13 times tangent of 32 is equal to x, because then these 13s cancel each other out. So now that x is by itself, this is what we type into our calculator. 13 times tangent of 32. So clear this out. 13 times tangent, remember tangent's all the way up the top now, of 32 degrees. And once you type that in, it gives you the answer in blue here. we'll just go to the nearest tenth, so we'll do 8.1. So x equals 8.1. They didn't give us any units, so we just leave it like that. So let's do one more similar to that one. We'll go to this bottom left one. It says, I am finding on the outside we see a variable x. Since it's on the outside, we are finding that side. So we set up our equation. Well, first, before you can set up your equation, since we're using that side, or sorry, since they gave us this angle 60 degrees, that's our reference angle. So from that angle, figure out your opposite side. Your hypotenuse side is always across from your 90-degree angle, and then the side left over is your adjacent side. Now we can set up our trig function. We have to use the side that we're trying to find and the side that we actually know the length of. So we're going to be using adjacent and hypotenuse. So if you go back up to your SOHCAHTOA, the one that uses adjacent and hypotenuse is the COS. So cosine equals adjacent over hypotenuse. So we use cosine. So cosine of angle B, which is 60 degrees, so you have to put the 60 in there, not just the B, is equal to the adjacent over hypotenuse, so x over 11. And then from there, you got to work towards getting that variable by itself. So to get x by itself, again, it's in the numerator, so we're going to multiply both sides by 11. So 11 times cosine of 60 equals x. And then now that x is by itself, we can go ahead and plug that into the calculator. So we're going to type in 11 times cosine of 60. Clear this out. 11 times cosine, not cosine inverse, of 60 degrees. And we get 5.5. So x equals 5.5. And again, since this is a side, it's not degrees. And they didn't tell us any units, like if they didn't say that 11 was 11 inches or anything like that. If they did, then we could actually put inches for this. But since they didn't, we won't. All right. So, based on those notes, I would like you to do this first assignment on, and it tells you to round to the nearest tenth for all these answers. On this first set, it says find the measure of each angle indicated, round to the nearest tenth. So I'm going to do one of each of these problems on your assignment to get you started, and then you can do the rest on your own. All right. So based on this one, and this is probably going to be kind of a lengthy video. Based on this one, find the measure of each angle indicated. So we're finding the angle. So on this one, that theta symbol is for angle A. So based on that, that's our reference angle. Figure out your opposite, your hypotenuse, and your adjacent sides. That's always step one. And I'm going to also write SOHCAHTOA at the top of my paper so I could see which formula to use. So when you're finding an angle, you need to use two sides that you actually know the lengths of. So we only know the adjacent and the hypotenuse sides. So the one that uses adjacent and hypotenuse is the cosine. So cosine of angle A is equal to the adjacent over the hypotenuse, so 12 over 13. And then you got to work towards getting that A by itself. So when remember, when you're finding an angle, you end up having to use the inverses. So to get A by itself, we have to get rid of the cosine, so we do cosine inverse of both sides. So when we do that, that cancels out the cosine on the left side, so we're left with A is equal to cosine inverse of 12/13. So A equals whatever that is when we type it into the calculator. And if there's not enough room to do all your work on here, you can always do it on a separate sheet of paper, of course. So we clear this out, and we do cosine inverse of 12 divided by 13. . And we get an answer of 22.6. And this is degrees because we were finding an angle. So that's how you do those 4 problems there, because you're finding the angle. Down here, it says find the measure of each side. So I'm going to do this first one here. Wherever the variable is, that's the side they want you to find. Whatever angle they give you, that's your reference angle. So angle B is our reference angle. Figure out the opposite side from there. The hypotenuse side is across from the 90-degree angle. And then the one left over is your adjacent side. Whenever you're trying to find a missing side, you got to use the side that you're trying to find and the side that you know. So we're going to be using adjacent and hypotenuse. So, because that's the hypotenuse is the side we don't know, adjacent side is the side that we do know. So that's why we use those two. So adjacent and hypotenuse, again, is cosine. Cosine equals adjacent over hypotenuse. Let's scoot this up a little bit. So cosine of angle B, which is 37 degrees, because that's our reference angle, you have to put the number in there, is equal to the adjacent side over the hypotenuse side. So 11 over x. Now that you have your trig function set up, now it's all about just getting that variable by itself. Now this time our variable's in the denominator, so we got to get it out of the denominator by multiplying both sides by x. So that gives us x times cosine of 37 is equal to 11. And then it's still not by itself, but we have x times cosine of 37, so the inverse of multiplying is dividing, so we're going to divide both sides by cosine of 37. So we get x is equal to 11 over cosine of 37. So that's what we're going to have to type into our calculator. So we're going to have to type in 11 divided by cosine of 37. Clear this out. 11 divided by cosine of 37. And we get 13.77, so that means this second 7 bumps that first 7 up to an 8, so it's 13.8. Okay. And then down here, I only want you to do one of these. So we're going to cross out 11, cross out 12, and cross out 10. Okay? And what they want you to do is, and I'm not going to do this one for you, they want you to find, it says solve the triangle. So that means find all the missing sides. Actually, you know what? We're just going to skip this one. We're going to skip. It's too much work when we've got other things to do. So we're just going to skip that whole bottom side. Okay? So I only want you to do 1 through 8 on this page, just to save you on time. Okay? All right. So moving on, we need to do some word problems now involving trig. So it says the horizon. So they're going to talk about angle of depression and angle of elevation. So you need to realize what those are so you know what you're looking for. It says the horizon line created with the object is parallel to the ground. So think of the horizon like a sunset, the ocean and everything. That horizon line where the ground meets the sky, that's horizontal. Angle of elevation is the angle created with the lower horizon line and the lower object. So here's an example where a person is looking up an airplane. We have two horizontal lines. We've got the one for the person's eyesight and one for the plane's eyesight. So angle of elevation is the angle created by the lower person looking up at the thing up in the air. So that's your angle of elevation. The angle of depression is if you're the higher figure, like in this case the airplane, and it's the angle created from that horizontal line looking down at the second image, or the second thing, so looking at the lower image, or the lower person. So this is our angle of depression, this is our angle of elevation. So think elevate, you're looking up, depression, you're looking down. All right? Suppose an airplane is about to land and will approach an airport at a 3-degree angle of depression. So here you have your plane. Instead of drawing it, I'm just going to write plane. Here's its horizon line, and it's got a 3-degree angle of depression. Okay? If the plane must descend from 35,000 feet up in the air, find the distance x along the ground between the airport P and the point Q directly below the airplane. I might have drawn this figure wrong. So let's think plane. If the plane must descend 35,000 feet, so that means the plane is 35,000 feet above the ground. So that's going straight below the plane to the ground. This would be 35,000 feet. Okay? Find the distance x along the ground between the airport airport point P and point Q directly below the plane. So this would be point Q directly below the plane. The plane's coming in down to the airport. And we're using point P for the airport. Okay, so it's flying down to the airport, and point Q is directly below the plane, according to this paragraph. And what they told us was, here's that horizon line for the plane, that this angle here is 3 degrees, that angle of depression. So I guess I can still use that. Oh well. What do they want to know? Find the distance along the ground between the airport point P and the point Q directly below the plane. So this is the side we're trying to find. Oh, sorry, I'm going to scoot that up. So here's your plane. Here's your 3-degree angle of depression. Here's point P, which is representing the airport. Here's point Q, which is representing the point on the ground directly below the plane. And they told us that the plane was 35,000 feet in the air. So that means this side has to be 35,000 feet. So this is our 90-degree angle. They want to know the distance between these 2 points, so this side here. And we have to use that information along with trig to find that distance. Now, the one good thing that we know is, and I'm going to have you put it up in your notes up here, that these 2 angles, since this is a parallel line to this line, and we've got our transverse, Lord, I've been home too long, transversal line, the line that's intersecting both parallel lines, then these would be opposite interior angles, so they'll be equal to each other. So the angle of depression equals angle of elevation. So for that same reasoning, let me sketch this up a little bit more. This horizontal line and this horizontal line are parallel to each other. Here's our transversal. This angle of 3 degrees is the same as this angle, 3 degrees. Okay? So now we can ignore this over here. We have our right triangle where we know one side and one angle, and we can use trig to find that missing side. All right. So angle P is our reference angle. So now that our diagram is drawn, I'm going to switch colors so you can see. This is my reference angle now. So now I'm doing my work in pink. So that means this is my opposite side. This is my hypotenuse side because that's across from my 90-degree angle. And then this is my adjacent side. So what we're trying to find is this adjacent side. And so we got to use that side along with the side that we already know. So we got to use the opposite and adjacent sides. And I have SOHCAHTOA right here for you. Here's SO, here's CA, here's TOA. The one that uses opposite and adjacent is tangent. So we'll be using tangent to set up our trig function. Tangent of angle P, because that's our reference angle, since that's the angle we knew of that right triangle. So tangent of tangent of 3 degrees, if you know the angle, you got to put the number in there, is equal to opposite over adjacent, so 35,000 over the adjacent side, which is x. And once you set that up, It's all about just getting that variable by itself. So we need to get it out of the denominator by multiplying both sides by x. By multiplying both sides by x, we got it out of the denominator, but it's still not quite by itself. Since it's x times tangent of 3, we need to divide both sides by tangent of 3. So we get x is equal to 35,000 divided by tangent of 3, and then plug that into our calculator, now that x is by itself. So clear this out. 35,000 divided by tangent of 3. So remember, whenever you're finding a side, you're using the regular sine, cosine, and tangent. Whenever you're using finding an angle, that's when you're using the inverses. All right, so we get 667,839 point, and this will be that 8 bumps that 7 up to an 8. So I'm going to go ahead and write this down while I have it on my screen. 667,839.8, and this is feet because the 35,000 was in feet. So if your plane is only, if its angle of depression is only 3 degrees, which is a small angle, then this distance, if it's 35,000 feet in the air, then this distance, 667,839.8 feet, is that distance from where the plane is, where the point on the ground right below the plane to the airport. All right. Let's do a few word problems and then a few more examples, and then I'll have an assignment for you. All right, so your goal for every one of these, remember, when you're solving for a side, you have to get the variable by itself using sine, cosine, or tangent. When you're finding an angle, then you got to use the inverses, sine inverse, cosine inverse, tangent inverse. Your very first thing should always be to draw a picture of whatever the word problem is describing. A lighthouse keeper at the top of a 200-foot cliff above the ocean shore sees a boat at a distance from the shore. I'm going to read it out loud, the whole thing, and then reread it to draw. So a lighthouse keeper at the top of a 200-foot cliff above the ocean shore sees a boat at a distance from the shore. The angle of depression from the lighthouse to the boat is 43 degrees. How far is the boat to the nearest foot from the base of the cliff? So we have a lighthouse at the top of a cliff, okay? And then there's a boat in the distance. Here's the water. And then we have our boat. Okay? Where the water meets the cliff, they meet at a 90-degree angle. So here comes our triangle. And this was the cliff. Okay? So as far as measurements, a lighthouse keeper at the top of a 200-foot cliff. So we know this cliff is 200 feet. Okay? Above the ocean shore here. So here's the ocean. Sees a boat in the distance from the shore. The angle of depression from the lighthouse. So if I draw my horizontal line, that angle of depression is 43 degrees. And just as a reminder, if that's 43 degrees, then based on alternate interior angles, this one is also 43 degrees. Then how far is the boat to the nearest foot from the base of the cliff? So from the boat to the base of the cliff, that's that side we're trying to find. That ocean. The side that I have labeled ocean. Sorry, got a little messy in there. So we're trying to find that side. Same kind of setup as the last one, which you'll see kind of common with these kind of problems. Now we're going to actually do the work. So we have our right triangle. We can now ignore this outside information here. We have our right triangle where we have an interior, we have one of the angles and we have one of the sides. So based on that angle, this is our reference angle. This is our opposite side. Hypotenuse side is always across from the 90-degree angle, and then this is our adjacent side. Okay? So our reference angle is the 43 degrees. We're trying to find this adjacent side, so we have to use the adjacent side. And we know the opposite side, so we've got to use whatever uses opposite and adjacent. So again, I like to have SOHCAHTOA right at the top of my paper, so I can remember my formulas. So the one that uses opposite and adjacent is tangent. So tangent of our angle, our reference angle, which is 43 degrees, is equal to opposite over adjacent, so 200 over x. And then we use our same algebra skills to get x by itself. So I'm going to, since it's in the denominator, multiply both sides by x. That cancels out the x's on the right, leaving just the 200. Then to get x by itself, we divide both sides by tangent of 43. So that cancels out the tangent 43 on the left side, so we're left with x equals 200 divided by tangent of 43. And that's what we type into our calculator. Clear this out. 200, oops, not plus, clear that out again. 200 divided by tangent 43. And we get 214.5 when you round correctly. And since that was the side that we were trying to find, and our other side was given in feet, it's 214.5 feet. I'm going to do maybe one more problem on this page and one more problem on the next page, and then we will let you do your assignment because I don't want to bog you down with too many notes. All right. So, I'm trying to see which ones I want to do then. Definitely want to do the latter one on the next page. Let's do, we've been doing some angle of depressions. Let's see if we have an angle. Let's do the boat, or sorry, this pedestrian ramp one. See what that gives us. A pedestrian ramp to the entrance of a building. So think of like a wheelchair ramp for a disabled person. So a pedestrian ramp to the entrance of a building. The measure of the angle made by the ramp and the ground can be no greater than 12 degrees. And the entrance is 3 feet above the ground. What is the minimum length for the ramp to the nearest foot? So the greater the angle, the less length of the ramp then. So we're going to go with that whole 12 degrees. So 12 degrees is made by the ramp and the ground. So here's your ramp. Here's the ground. And then where the end of the ramp ends, right above the ground, that makes a 90-degree angle. So it says, for the pedestrian ramp to the entrance of a building, the measure of the angle made by the ramp and the ground can be no greater than 12 degrees. The entrance is 3 feet above the ground. So here's the door to get into the building. I'll put entrance here. Above the ground, the entrance is 3 feet above the ground. Okay, and what is the minimum length for the ramp to the nearest foot? All right, so we need to find the ramp length. So that's our x side. All right, based on our diagram, our reference angle is at 12 degrees because that's the side we know, or that's the angle we know. Opposite of that is that 3-foot side. the hypotenuse is the ramp, and then the adjacent side is the ground. Okay? So we need to set up our equation, our trig function. So when we're trying to find a side, we've got to use the side that we're trying to find and the side that we actually know the length of. So we'll be using opposite and hypotenuse. So opposite and hypotenuse uses sine. So sine of that angle, 12 degrees, is equal to the opposite side, which is 3, over the hypotenuse side, which is x. That's the side we're trying to find. And now that we have our trig function set up, we can go ahead and work towards solving to get x by itself. So we have to multiply both sides by x. And then get x by itself by dividing both sides by sine of 12. So x is equal to 3 divided by sine of 12. So we'll plug that into our calculator. Clear this out. 3 divided by sine of 12. We get 14.4. And since this side was measured in feet, the ramp is 14.4 feet. So this is how we would use trig in real life to figure out how long to make something, or in this case, how long we would need to make that ramp. Or with the plain one, how far on the ground we're still away from the airport. And on this one, to have an idea of how far that boat is still from the cliff. Okay, I'm going to go ahead and skip that next example on that page so I can at least do one example on this page, and then I can give you your assignment. That way we're hitting an hour now on this video, and I don't want to spend too terrible much time. So I'm going to do, here's the last page of our notes. And what I'll do is I'll go ahead, before I upload these notes to It's Learning, is I'll go ahead and work out all the problems. That way if you need to see some more examples, you can still see those examples without having to physically go through these with me on the video. But on this page, I only want to do that middle problem, the 30-foot ladder one. So it says, a 30-foot ladder leans against the building, making an angle of 72 degrees. So here's our building. Here's our ladder. And here's the ground. Where the building and the ground meet always makes a 90-degree angle. All right, so it says a 30-foot ladder, so it tells you how long the ladder is, 30 feet. It leans against the building, making an angle of 72 degrees with the ground. So the angle that the ladder makes with the ground is 72 degrees. How high on the building does the ladder reach? So here's the height of the building. We're trying to get that distance to see where the ladder reaches the building. Find it to the nearest foot. So when they say round to the nearest foot, that means round to the nearest whole number. Okay, so let's go ahead and work this out. We have our diagram. We have a reference angle. The 72 degrees is our reference angle. So across from that is our opposite side. Across from the 90-degree angle is our hypotenuse side. And then the ground is our adjacent side. So we need to set up a formula or a trig function to where we are trying to find the side. So we got to use that side, and we got to use the side that we already know the length of. So we'll be using opposite and hypotenuse. And again, I like to have my SOHCAHTOA in front of me. The one that uses opposite and hypotenuse is sine. So we'll be doing sine of that reference angle, 72 degrees, is equal to opposite over hypotenuse, so x over 30. Now that our trig function is set up, we can go ahead and solve for x. So we'll multiply both sides by 30 to get x by itself. Multiply by what's in the denominator. So we got 30 times sine of 72 is equal to x. X is by itself now, so we can go ahead and plug 30 times sine of 72 into our calculator. clear this out. 30 times sine of 72. And we get 28.53, but remember they told us to round to the nearest foot, so they want us to round to the nearest whole number. So 28, and then you notice to the right of the 8 we have a 5, so that 5 bumps up that 8 to 29. Oops. So x equals 29, and since the ladder was in feet, we use feet for our unit. And there you go. All right, again, I will do those other examples that we did not do and fill out the notes completely, so if you need to see some more examples work out, you will see them. You just won't hear me go through them with you. Your second assignment is to do these 5 word problems. Don't forget about number 5 at the bottom. There's not a whole lot of room for it, but it is still there. I will do number 1 with you. Actually, that one's just like the one we did in our notes. So I will do number 2. So that way you have one problem done on your homework so that you can use that to help you out. All right. I'm going to write SOHCAHTOA at the top of my paper. So I like to have it there on every single page with me. All right, Mrs. Bailey has a 20-foot ladder that she leaned against the wall. That's really similar. Oh, no, but we're finding an angle this time. So Mrs. Bailey has a 20-foot ladder that she leans against a wall so that the foot of the ladder is 8 feet from the base of the wall. So let's draw our right triangle. Where this is the building, or wall in this case. This is our ladder leaning up against that wall. And this is the ground. Said it's a 20-foot ladder that she's leaned against the wall so that the foot of the ladder, so the base of the ladder, is 8 feet from the base of the wall. So that means this ground distance is 8 feet. So the foot of the ladder is 8 feet from the wall. What is the measure of the angle to the nearest degree that the ladder makes with the wall? So the angle where the ladder makes with the wall, that's our angle. Okay, so I just put that theta symbol in there so it's similar to ones you've seen in the past. But we can go ahead and label this as like angle A, this is B, and this is angle C. Okay? Alright, so in case you'd rather use letter A rather than theta. Alright, so now we got to set up our trig function to find that missing angle. So this is like the problems that we did at the beginning of our notes. So the angle we're trying to find, that's our reference angle. Use that to help you figure out the opposite side. The hypotenuse side is always across from a 90-degree angle, and the last side is always your adjacent side. So now, whenever you're finding an angle, you have to use the 2 sides that you actually know the lengths of. So we know this 8 feet and that 20 feet. So we know the opposite and the hypotenuse sides. So we got to use the one that uses opposite and hypotenuse, so that will be sine. So we're going to use sine of A, because that's the angle we're trying to find, is equal to the opposite side over the hypotenuse side. That's what that so means. Sine equals opposite over hypotenuse. So 8 over 20. And now our trig function is set up. Just remember, when you're finding an angle, you still got to get that angle by itself. We got to get A by itself, so that means we got to get rid of the sine. The way we get rid of sine is do the sine inverse. So we take sine inverse of both sides. So that leaves us A is equal to the sine inverse of 8 over 20. And then that's what we type into our calculator. So sine inverse, oops, clear this out. Sine inverse of 8 divided by 20. And that gives us an angle of 23.57. So that would be 23.6. If they don't tell you what to round to, just round to the nearest tenth. So 23.6 degrees. All right. So your 2 assignments are this word problem page. This is your second assignment. Finish those other 4 problems. And then finish, sorry, let me zoom this out a little bit so you can see better. So your 2 assignments is this one labeled assignment 1, where I canceled out the bottom 4 problems, so you're not doing 9 through 10. You just have to do 1 through 8, and we did 2 of those together. And then your second assignment is these word problems. Go ahead and do 1, 3, 4, and 5 on your own then. All right, that's what's for this week. Sorry the video is so long, but there was a lot to cover. And then this will be the last bit of trig, I think. I'm not sure if we use any of that in the next unit or not. All right, have a wonderful day and enjoy your week. And then you can always come see me for help in those meetings online. Just click on either the Thursday meeting or the Friday meeting, depending on what day you're wanting to meet with me. Have a great day, guys.